Okay, I turn on the record. So it's initially Vancouver Snowflake user group, but I also manage Calgary one and Toronto. And basically, I published this meeting invite about this event to all groups, certainly with Snowflake community and with LinkedIn. So this is dedicated page on user group Snowflake that unfortunately wasn't updated. So I tried to reach to community team in Snowflake, so they didn't get back to me. So whatever we'll finish, we'll record this event and publish back. So Nikolay, word to you. So feel free to share your screen, and if anyone has questions, you can publish in the chat. And don't forget to introduce yourself, Nikolay, one more time. Yeah.
Yes, thanks a lot. So let me share my screen. Yeah. My name is Nikolay Golov. I'm responsible for all data platform in ManyChat company, and I want to tell you a story how we selected Snowflake, how we used it for a year, and what results we have achieved. So first of all, let me briefly introduce you my company, ManyChat, to explain what are we doing for living. 1 second. It's always with video. So short video, because it's faster to show you videos than explain it by words. So ManyChat is a tool for creating a chatbots without coding. It's no coding tools for creating a chatbots. Mostly chatbots inside the Facebook, but we also support emails and SMS, and currently we are working on adding an Instagram and WhatsApp. And here you can see the countries which consider the ManyChat as a most popular chatbot tool in the world. You can see that a lot of countries consider ManyChat as the best tool for chatbot creation, for chatbot generation. So it's a story about company, nothing interesting here. Now about size of the company. So ManyChat have few 100,000 of paying customers, a few million registered users. We support millions of working chatbots. I suppose currently about 3 or 4 millions. We have billions of subscribers, because each chatbot have few subscribers, and if a person is subscriber to multiple chatbots, he is calculated multiple times. That is why we have billions. I suppose you can compare it with the population of Earth, but we still have them. And we process tens of billions of messages per week, which are being sent through our platform. It's a communication between chatbot and a subscriber in a Facebook and email, SMS, and so on. So we don't see the messages, but we can see the fact of communication, and it theoretically can be used for analytics. And currently here are pain points of ManyChat, which I was faced at the end of 2019 when I was hired. So ManyChat in 2019, ManyChat already was a profitable company with a huge part of the market, but ManyChat had some issues with analytics. And when I was hired, I tried to study those pain points. So pain points are rather traditional ones. So speed, analysts have issues with slow queries and dashboards, because They have used for analytics. They use Postgres, sometimes Redshift. So I suppose you understand why queries were slow. They have issues with volume. They were not able to analyze full clickstream because there were billions and 10 billions of rows. There were a lot of issues with data inconsistency between different types of data from Google Analytics, from Facebook, from our own databases, from CRM. And complexity. We had a lot of complex attribution models which we cannot analyze, which we cannot fully analyze inside our existing analytical system. So traditional pain points, and at this moment we decided to that we need some new analytical system. We decided that we have to implement we have to select some analytical columnar database. We have to upload all data inside it and build analytics above it. So rather traditional approach. When we started selection process, it was December of 2019. We decided that our initial filter for databases is following. So our database shall work inside Amazon Web Services because all our backend resources were hosted by Amazon Web Services. Our analytical database shall support NCSQL. Our new analytical database shall support modern BI tools like Tableau, ClickView, Power BI, or Looker. And it shall be scalable. It shall be able to support growing size of our business. And speaking about Amazon Web Services, it was important to select a database which can work inside Amazon Web Services, but we wanted to avoid a vendor lock. We wanted to avoid cases that we can change Amazon Web Services for example, Amazon Azure or Google Cloud. So we wanted to have some flexibility. And in this moment, there were 4 candidates who passed through our filters. It was Snowflake, it was Vertica, Vertica L mod for Amazon, it was Exasol. Maybe some of you know it. It's a German database used by Revolut and Adidas and other companies. And MemSQL, rather unusual case, but we wanted to try it. How we performed the selection process. For each database, we created a data sample. We created a set of analytical tasks for those data. Those tasks and those data samples, they were modified for each database. So we can check data loading process for each database and send analytical queries to those data to check their speed, their efficiency, their ability to process, the ability of database to process complex SQL queries. So it's like a flow of selection. How we performed the selection process? We launched a trial instance of each database, of each of 4 databases. We uploaded sample data in each database, and it was test number 2. Are those databases are able to load those data with a high enough speed. We launched sample analytical queries to those data for each database. And at the beginning, we calculated a total cost of ownership for each database. I can say, the slide is about how we estimated a total cost of ownership. I've tried to estimate growth and calculate future volumes of data, which our new analytical database shall be able to adopt to store inside it. I suppose seeing the name of the current webinar, you understand that Snowflake won. I can tell that from from 4 candidates, 3 candidates, Snowflake, Exasol, and Vertica, they survived loading tests and SQL analytical queries test. They showed comparable results. In some tests, one database was better. In other case, other database was better. But in general, they was comparable. MemSQL, it's a database about different types of workloads. So in functional tests, it left competition. But when it went to a comparing of total cost of ownership for 1 year and for 3 years, Snowflake was clear leader. I suppose if some of you are using Snowflake, you understand why. And important point here, when I have estimated total cost of ownership for Snowflake, I was making a lot of assumptions because I don't have experience with Snowflake. I had an experience with Vertica and with Exasol, but no experience with Snowflake. I have tried some forecasting, but I was not sure that my forecasts for money will be correct for Snowflake. But I can tell that when a year of usage have passed, in the December 2020, I have checked whether my plans, whether my forecast for Snowflake was correct, and I can tell that I have forecasted total cost of ownership for 1 year, and my real credit consumption was just 3% higher than my initial estimation. So I suppose those forecasts was very, very accurate. Here you can see it's this graph shows a weekly spends of Snowflake credits. Blue line is the weekly spends, and the red line is a yearly budget, just divided by number of weeks. So it's like normal level of consumption. And here you can see that at the beginning of 2020, there were almost no data in Snowflake, almost no usage. So credit consumption was very low. Afterwards, you can see that, I suppose, up to August of 2020, credit consumptions was growing because we were uploading more and more data, adding more and more ETL processes, adding more and more analytical processes, more and more Tableau dashboards, more and more calculations to our analytical database. So credit consumptions was growing. But at the August, we almost finalized data model. And here we switched from uploading a new data without thinking about efficiency. We switched to efficiency. We switched to optimization. And you can see on those graphs that our work resulted in some success. So we successfully optimized our credit consumption, and weekly consumption started to become lower and lower. Meanwhile, the amount of data loading daily, loading hourly on a regular basis was growing with each coming months. And regardless of those optimization processes, we successfully solved all analytical points that I have mentioned at the beginning of my presentation. So we solved a problem with a complex analytical queries, with the ability to analyze clickstream, with the ability to create complex attribution models. All those stuff was successfully solved at top of our analytical database. Here you can see graph of credit consumption for 1 year, but now it's March of 2021, and I can show you like extended graph. You can show that for 2021 we increased a little our forecasts of, we increased a little our yearly budget, but you can see that weekly spends of credits go even lower because we continue our optimization process, and because we do the very fundamental optimization, those optimization affect all our processes, and credit consumptions going down for absolutely all processes, regardless of the fact that we are constantly adding a new data, that we are constantly expanding our data, we are constantly connecting new data sources for our data warehouse. I hope that we can achieve much better results. We can drop it even lower. And I can say about the data volumes, I can say that current size of our data warehouse, it's about 16 terabytes in terms of Snowflake, and in terms of raw data before uploading to Snowflake, it's about 60 terabytes. So currently we are working with 60 terabytes, which are very efficiently compressed by Snowflake and very efficiently analyzed there. And those volume is constantly growing because our business is growing, not that fast as we want. We will always want to grow faster, but our business is growing, and uploading data from a growing business, our history is constantly growing more and more. So I suppose soon we will have 60 terabytes and up to 100 and even more. How we achieve those efficiency, how we achieve what architecture of data warehouse we use for our analytical database based on Snowflake. We have three main areas, three main zones inside our Snowflake database. We have staging area, which store data from external sources in a JSON format without transformation, very simple, huge tables, which store just JSON, tens of billions of JSONs. It's like you can observe this staging area as a huge data lake of semi-structured data. Very understandable, very efficient tool, very efficient part of our ETL. Second part of our data warehouse is a detailed data store, where we store full model of our business with a very high level of normalization. We use a 6 normal form. So what does it mean, 6 normal form? It means that each attribute of each entity, for example, of each client, is stored inside a separate table. So for each attribute, we independently store its historicity. Each table and each anchor modeling, it's a simple entity relation model. So here we have entities like clients, goods, payments, all those stuff. We have attributes of entities. So each client have, for example, name, so name, like region, something about it, and we have a relation. So each person can have a relation with, for example, chatbot. So some chatbot can belong to some person. So very simple relation. And in those model, each attribute and each relation, it's fully historized. So we store all attributes, all relation with historicity to the beginning of time. So full data model, full representation of our business. But of course, this detailed data store, it is convenient for storage, but it's not very convenient for analysts. So that is why we have a third part of our data warehouse. It's a data marts. Data marts, they are created above detailed data, and data marts they consist of denormalized data marts. Sometimes it's star schemas, but mostly it's a like single denormalized data table, which can be used for as an input for a Python machine learning algorithms, or they are used as a data source for Tableau reports. And those data marts, they are created by analysts. Creating those data marts, they like combine raw histories data and augment it with some business logic, with some with some logical aspects, for example, for financial questions, for product questions, for some other questions. Yes. I suppose this picture, this approach is rather clear, rather traditional. So why it helps us to achieve why it helps us to use Snowflake so efficiently? Because we discovered that in Snowflake we can define like 3 patterns of usage. 2 of them are efficient, and third one is very inefficient. So first pattern of usage is we call it good case 1, many small everything. So if you have many small tables, it's a rather small in size or small in columns. If you have many small dashboards, many data-driven people, many data-driven analysts, you can work with such data with a large number of small virtual warehouses. So in terms of Snowflake, it is XS and S warehouses. Those warehouses are able to launch very fast cold start, and all analysts, all dashboards are not influenced by each other. Everything works great using a very cheap resources. So this scenario is good. Second scenario is a like scenario of big click stream. If in first scenario there were many small, here is one rare accessed big table. So huge click stream of huge table of JSON data, which are rarely accessed by some ad hoc analytics. This scenario requires rather big computational clusters like XL, L, and all those stuff. But it's also efficient because it is rare access, and those expensive warehouses are used a very small amount of time. So it is also not very expensive. But here we have a third scenario. It's inefficient one. Scenario is when we have many large tables, many regular big dashboards, frequent complex ad hoc queries, and these cases is very inefficient in terms of data, in terms of money, in the first place, because it requires constant usage of large expensive warehouses like L, XL, and all those stuff. So our idea was that we shall focus on a first case for all automatical process. So for regular ETL operations, we shall focus on the first scenario. For like ad hoc scenarios, we shall focus on the second scenario, and we shall at all cost avoid third scenario. We shall avoid constant automatic processing of many big tables. How we achieved it? So if you see, if you imagine our data warehouse and complex parts, let's start from filling a staging area. So filling staging area is filled from a data bus. So very simple processes. They are just taking new data from a database and appending it to huge JSON tables of staging area. No logic, just adding a new JSONs to existing tables. These processes are extremely fast, extremely efficient, and they can be supported by very small data warehouses. So XS data warehouse is more than enough for such operation. So we are constantly supporting few XS data warehouse which are performing like constant uploading of new data from database to our staging area. So they are working, they are avoiding any complex logic, and they are very, very cheap. So it's the first part. Second part is a movement of data from a staging area to detailed data. This operation is it requires transformation, and it requires comparing of data from staging area with existing data to enable a historical append. So enable to append data only if they are missing into detailed data store, only if something was changed. Here we strongly utilize that fact that staging area is incremental one, so each data are appended above all data, so we can easily take only new chunk of data, first of all. And second one, that because of 6 normal form, all tables of detailed data store, they are very narrow. They can contain very small number of columns. At most cases, there are 5 columns, no more. And that is why in most cases, we are able to upload those data from staging area to a detailed data store using very cheap data warehouses. We are able to upload them using XS warehouses for most of the data entities. Because, for example, we have 100,000 of paying customers, we have millions of customers, and XS warehouse is more than efficient for such operations. And only for some rare cases, which are affected by clickstream, because clickstream and all those messages, there are billions of entities, or sometimes tens of billions of entities in terms of messages. In such cases, we have to use S warehouse of size small. It is more expensive than XS, but it also rather cheap. And this approach, so only incremental chunk from a staging area and very narrow table inside a detailed data store, it gives us an ability to constantly use a lot of very cheap specialized data warehouses, because we have specialized data warehouse which is working only with loading of attributes. We have specialized data warehouse which is used only for loading relations, and same story for entities. And because of it, each data warehouse is first very cheap, and second one is that its cache is always contains actual data. We don't need to wait when actual data is uploaded to a working warehouse, because it is working with a small subset of tables and always contains actual data inside its cache, so it works very, very efficient. And one more benefit of the 6 normal form is that it is possible to upload all data in parallel. So really, entities first, and then all attributes and all relations, they can be uploaded in absolute parallel without dependencies at all. It's one of the best benefit of used methodology. And I suppose you understand why this process, why the process of uploading data into staging area, and why the process of loading data from a staging area to detailed data store, while both processes, they are scenario one, like many one, which can many small tables, which can be supported by very cheap data warehouses, regardless of the fact that some entities contains tens of billions of rows, but we still can work with them as if they are very small. And last part is a calculation of data marts. Here we sometimes have complex logic when some data marts shall be calculated by combining a lot of various data. Sometimes some data marts require complex SQL calculations. Sometimes some data marts require some data marts require usage of big clusters like M, or sometimes L clusters. But really, we very rarely use L clusters, large clusters, for automatic operation, because those data marts, in most cases. They can be calculated either rarely, so once per day, once per week, or they can be calculated on an incremental basis. So no recalculation of this of all the data mart for all history, but recalculation of last month. So drop last month, recalculate last month, and it is this volume of calculation is quite appropriate for a medium cluster, which is also which requires a reasonable amount of resources, especially if you launch it on the daily basis. So if it works only, for example, 1 or 2 hours per day, it don't work 24 hours each day. So I suppose I have successfully, I have tried to explain how we achieved those graphs, or how we achieved those optimization steps in parallel with giving our analysts ability to analyze all data of ManyChat, with giving them an ability to analyze all growing model of our business, because our business is constantly changing. We are, for example, now we started from just Facebook messages, but currently we are uploading SMS, emails, we are uploading Instagram messages, we are uploading WhatsApp messages, like facts of messaging in WhatsApp and Instagram and all those stuff. So data model is growing hugely, its complexity is growing hugely, but our analysts, it's now we have like few dozens of them, I suppose, more than a dozen, yes. They are still able to analyze all data that we want, that they want, and to test all hypotheses that they want to test. So thanks a lot for your time. I hope that my explanation was clear, because I suppose you can understand that English is not my native language, but I'm ready to answer your questions if you have one. Let me check what questions do you have. Yeah.
Thank you, Nikolay. Yeah, very good presentation. It was interesting to learn about your selection process, especially about your scenarios and the cases you did and how you compare other platforms. So as I said, we record this event, we will upload to YouTube and share with our meetup groups. And yeah, if you have any questions, feel free to speak up or drop message in the chat. So whatever you think will work for you.
So yes, I have seen some questions here. Yes, for example, first question for quality of forecasting. Yes, maybe it's more like 7%. Yes, I have calculated the difference in the Google Sheet. It gave me something about 6%. But I suppose you're right. Maybe I have some issue. Maybe I have had some issue with my formula. But I suppose you can see that error for 1 year forecast, error for 1 year forecasting are rather small. About using anchor modeling in Snowflake. Yes, I like anchor modeling. I see benefits of it. I just creator of anchor modeling is like my scientific tutor. So previously I have adopted it in Vertica and achieved rather good results there. And here I have I have compared different approaches, but finally I've decided that especially for Snowflake, the anchor modeling can benefit. And I have tried to explain why it can benefit. And those figures in credit consumptions, I suppose they prove that my bet was right. So it was when I decided to use it, I was not sure that I will succeed, but I suppose results are rather good. So how big are the tables? What is the largest number of joins? biggest entity of ManyChat is the messages. There are 10 billions of rows, few tens of billions. Currently, we don't have the entity with the hundreds of billions. I suppose we will have soon. We will have it, but I suppose I haven't checked current size, but 20 or 30 billions of rows for biggest entities. So all attributes or for these entities, they also consider 20 or 30 billions of rows. It's the biggest one. Other are much smaller. About largest number of joins. Joins, they are usually part of data mart calculation. So let me show you this part. I can't remember analytical query then with less than 5 or 6 joins. Usually there are 10 or 20 joins. So our analysts very like such approaches as subqueries, as a common table expression with clause, all those stuff, and afterwards they wanted to they like to join them together and join entities and relations to them. And sometimes there are 10, 20, 30, maybe more. I'm not sure about biggest queries that they use. Yes, building a denormalized data mart for Tableau or Python, it usually requires many joins, but it's a life of analysts. In all the data that we have in the data store, they are historized. And those joins, they also require analysts to think about how they want to work with historicity. They want to combine data for a current perspective, so latest perspective for a current moment of time, or if they're creating some financial reports, maybe they want to create, analyze like status of each our client to the end of each month. And when we force them to use many joins, they have to think about it and avoid avoid unnecessary mistakes which can be caused by using the data without thinking about historical aspect. Yes, but yes, the normalized table creation of the normalized tables require a lot of joins.
Hello, thanks Nikolay for the presentation and Dimitri for the organization of this meetup. I have two questions. So the first one is, you mentioned like as the time passes, your data size grows, and the growth rate you mentioned is really critical, but you also mentioned your Snowflake usage in terms of credits are decreasing while the time passes because of the optimizations you use. So you mentioned, like, you kind of talked about the size of the warehouses you use for each job you have within Snowflake. So obviously that's one, I assume that's one part of the optimizations you have. But other than that, what type of optimizations you are using? For example, I think last week I attended another webinar from Snowflake, which was talking about search optimization parameter being turned on for tables or something like that. So are you using anything like, basically I'm asking, like, what are the types of optimizations you are using?
What types of optimization we're using? Main idea of our optimization is to achieve maximize a scenario one. And if we're uploading a new data, the idea is that new data really they shall affect only like fresh part of the table. So if you are implementing uploading of new data without thinking of it, so uploading of new data shall be compared with all the table, and this operation is rather inefficient because size of the table is constantly growing, and so size of your query is constantly growing. So understand that key of success can be based on the usage of pruning mechanics of Snowflake, or on the creating some our own pruning approach above tables of Snowflake. So what mechanics do we use? I have planned to create a slide about it, but I was thinking that I will not have enough time. So let me explain it like orally. So main idea: if we are uploading some entity, for example, client, we have like millions of clients, but only few of those clients they are really actual client which are have changes during this week, during this month. A lot of other clients they are not active. There are no changes in them. So if we augment those table of clients with one additional field, we call it is active. Those is active field is used into cluster by clause. So table is sorted by it. So first of all, we have like active clients, and afterwards we have inactive clients. Those is active field is used only into ETL processes, is like invisible for analysts. And when we got a new data, first operation that we have, we take those entities table and update those rows which are not active, but we see new records for them. So we perform like efficient update. So really it's insert and delete update for like that part. And afterwards, all subsequent ETL processes, they are working only with those active part. And it gives us an ability to constantly work with just small actual chunk without taking all this huge history. And this approach, it have required some manual implementation of manual working with Python processes, but it gave us an ability to retain retain efficiency of our ETL processes regardless of the constant growth of target tables.
Perfect. Thank you very much. So my second question was actually tied to this. So you are mentioning a lot of like ETL processes within Snowflake. I'm actually investigating into this right now, and I was looking into dbt. So are you using dbt, or do you recommend any other tools for that?
I think dbt is good. My team was implemented everything with our hands because we have very deep understanding of ETL process, and we just prefer. We have a great experience, for example, with Airflow. We have some experience with dbt, but because we have, it's a dangerous choice, because if you need to start implementing ETL, if you make a choice that you will want to make everything with your hand, you have to be sure that you will succeed, that you will make everything that you need on your own. And because I have a great team, I have a few great engineers in my team, and I was sure that we will succeed. Each of us have such experience. So we just implemented everything, every parts of ETL with our hands, and it gave us a great flexibility in tuning it. But I suppose in a lot of business cases, I will strongly recommend to use some well-known tool like dbt or like Airflow.
Okay, perfect. Thank you very much. I appreciate it.
Yes. Here I see a new question. on the subject of clients, how do you solve problem? A customer record consolidation. So issue of matching data from various sources. Currently, I can say that our startup are still rather consolidated. So we almost don't have such cases when we have to integrate various like data sources with unmatched entities. But in my previous job, I was solved these issues by creating like a separate matching table, which is used to match entities from table from source one with the entities from a table two, and to upload them into single entity of data warehouse. But it also requires some tool for working with those matching table, for populating it with some logic, with regex logic, all those stuff, but it constantly have some small part of the data which can be matched automatically, and you have to somehow match them by hand or ask somebody to match it for you. So it's constant issue. The only solution that I know is matching tables inside our system, which is used to combine data, for combining data. Yes. So I suppose that's all questions that we have. If somebody have some question, you can ask them. I suppose we can wait for 1 or 2 minutes. And regardless of it, thanks to everybody. I was happy to explain you our results, to describe you our year of existence of our analytical data platform.
Yeah, thank you, Nikolay. It was a great presentation. Thank you for detailed answer for the question. So I think we have very good timing. So it's like 15 minutes and people have more time to do other things. So I'll call it the end of the user group. And thank you for coming and presenting. So yeah, have a good day, everyone. Bye.
Thanks. Bye.